Hey Shannon, what kind of energy does the Big Dipper have at the top of the hill?
Hey, it's moving. What kind of energy do you think it has now?
Well, since it's moving and it's no longer at the top of the hill, the gravitational potential energy is transferred to kinetic energy. We measure kinetic energy by multiplying mass by velocity squared, then divide by the product by 2.
Yeah, I got it. Great question, Haley. Well, when an object is above the ground or above the zero position, the object will have gravitational potential energy, meaning the amount of energy it has when gravity is acting on it at a height higher than 0 meters. We measure it by multiplying the object's mass by force of the Earth, negative 9.8 meters per second squared, by the height.
Cool.
Hey look, bumper cars!
Those are so fun, but I don't like it when people run into me. I always get pushed backwards.
That's only because the kinetic energy of the car is transferred to elastic potential energy when you and another bumper car hit each other.
Oh, got it. Is it an elastic collision or an inelastic collision?
Inelastic, because you don't stick together when you hit each other at the end. An inelastic collision occurs when two objects run into each other and stick together. But when you and another person bump into each other and then break apart again, like bumper cars, it's called an elastic collision. You don't stick together, and the force you hit with each other will cause each other to go outward. I wonder how fast these bumper cars go.
Oh, that's easy to figure out. All we have to do is multiply acceleration by time, then add the initial velocity. For example, if we multiply 5 meters per second squared by time, 10 seconds, then add the initial velocity, which is only 0 meters per second, we will get our final velocity of 5 meters per second.
Wow, that's pretty fast.
Well, it's just an example. Don't the bumper cars have momentum when they drive at each other?
That's right, Haley. They do have momentum. We measure momentum by using the equation P equals mv, or momentum equals mass times velocity. If the mass of a car is 50 kilograms and the velocity is 10 meters per second, the momentum is 500 kilograms times meters per second. Cyclone, I love this ride!
There are a lot of physics going on here too.
Oh really? Like what?
Centripetal force for one. When the ride is spinning, the centripetal force or center-seeking force is acting on the ride and riders. For example, the force exerted on a rider is measured by multiplying mass by acceleration. If a rider has a mass of 70 kilograms and an acceleration of 9.8 meters per second, the force acting on the rider is 686 newtons.
Wow, that's a lot of newtons! Got it. Doesn't Cyclone have circular motion too? Can we find its velocity?
Yes, we can, Shannon. We can use the equation velocity equals 2 times pi times the radius, all divided by time. For example, if the ride of the cyclone has a radius of 5 meters and a time of 15 seconds, we just multiply 2 times pi times 5 divided by 15 seconds, and we get an acceleration of 2.1 meters per second squared.
Awesome! The Cyclone sure does sound like a really fun ride. Wow, Haley, there sure are a lot of physics here at the boardwalk.
There sure are. Yay, physics!
Yay, physics!
She moves her body like a cyclone, and she makes